We know that a single bond is a sharing of a pair of electrons. That is a single bond. Well, a single covalent bond has a special word. It's called sigma bonds. Sigma bonds occur when the pair of shared electrons is in an area centered between the two atoms. These are sigma bonds. So whenever you see a single bond, it is a sigma bond. And sigma is represented by this symbol right here. It kind of looks like a sideways 9. That's a sigma bonds. Now, double bonds form when two pairs of electrons are shared between atoms. Now, the first picture gives you oxygen, two oxygen molecules coming together, and now you have two shared pair of electrons between there. That is a double bond. And your double bonds have a sigma bond, which is the first one. This one right here is a sigma bond, and the second bond is called a pi bond. So when you see a double bond, you have one sigma and one pi. Triple bonds form when there's three pairs of electrons shared between atoms. Here is a triple bond. Look, you have one sigma, one pi, and another pi. So you have one sigma bond and two pi's. Double bond, two shared pairs of electrons. A triple bond is three shared pairs of electrons. So, and this is a picture of your pi bond. When you have multiple covalent bonds consisting of sigma and at least one pi bond, the pi bond is formed when you have parallel orbitals overlap and share electrons. So, the picture here shows this is your sigma bond, okay? So, you can have two more bonds, which are pi bonds. So, this is an overlap of those electrons forming that pi bond. And you could do even another one so that you could have two pi bonds if it was a triple bond. So double has this one, and then triple is this one, and this one. And it is an overlap of these orbits coming together and bending. So when we get into these different bonds, these single bonds, double bonds, and triple bonds, there's a strength change. The strength of these covalent bonds change. And the strength depends on the distance between the two nuclei, the bond length between the two. So as the length increases, they get further apart from one another, the strength of that bond decreases, which means it will take less energy to break that bond. So in a covalent bond, a single covalent bond is not as strong as a double covalent bond, which is not as strong as a triple covalent bond. If you look over here at this last column here, you will see that as you increase the number of bonds, you are decreasing the distance between the two. The closer the nuclei are, the stronger they are attached. So a triple bond is much stronger than a double bond, is much stronger than a single bond. It will take more energy to break the triple bond than the double bond, than the single bond. So, as we continue to talk about the strength of these bonds, when a bond is formed, energy is released. Remember, that's what nature wants, a lower energy state. That's why so many things exist as compounds and not just as individual elements. They are forming bonds, they are releasing energy. So energy is released when a bond is formed. Energy has to be added to a system to break the bonds. And the amount of energy required to break a bond is something called the bond dissociation energy. Dissociate means to break apart. The amount of energy required to break the bond is bond association energy. Bond dissociation energies are always positive. They are always positive because they are put in the system. Whatever reactions you're doing, energy is put into it. When energy is put into it, it is endothermic, which means it is going to have a positive value. So as I was saying, endothermic reaction is one where a greater amount of energy is required to break a bond in reactants than is released when the new bonds form in the products. An exothermic reaction is one where more energy is released than is required to break the bonds in the initial reactants. It is very important to know the difference between endothermic and exothermic. So let's review. First off, what is a covalent bond? How does it differ from an ionic bond? I hope you're thinking in your head a covalent bond is a sharing of an electron or electron pairs, and ionic bonds are complete transfers of electrons. How does it differ from an ionic bond? Well, because ionic bonds are transferring electrons and covalent bonds are sharing electrons. Now, what is a single covalent bond? A single covalent bond is only a bond between a pair of electrons, just one pair. And why does it form? Because when it forms, it's going to get to a lower energy state, and nature prefers a lower energy. Now, what's the difference between a sigma bond and a pi bond? Well, a sigma bond is just simply a single pair of electrons bonded together covalently. A pi bond is actually a double pair of electrons bonded covalently. A single bond would be a longer distance between the nucleus. A pi bond is going to be the distance between the nucleus is getting shorter. So a pi bond is stronger, requires more energy to break a pi bond than it does a sigma bond. And how is bond length related to bond dissociation energy? Well, I just talked about it. The closer the bond, the closer together the nucleus, the more energy it takes to break a bond, the bond dissociation energy. The further they are away from each other, the less energy it takes to break bond. Okay, so now that we know about bond length, sigma bonds have the shortest length, and then pi bonds, a double bond would be, sigma bonds have the longest length. That's a single bond. Then a double bond is going to be shorter. Triple bond is going to be shorter. So that means a triple bond requires more energy to break than a double bond or a single bond. So let's look at the not resonance structures. Sorry, I'm getting ahead of myself. Let's look at the Lewis structures for these three different molecules. So sulfur has 6 valence electrons, and so does oxygen. However, I've got 2 oxygens, so that's 2 times 6, which is 12, plus 6 give me 18 electrons. So I have to have 18 electrons go in my Lewis structure. Now, the first thing I want to do is put the least electronegative element in the center. So sulfur is going to go in the center, and then oxygens will go on either side. Now I have 18 of them, so I've got 2 in the dash, 2, 4, 6, 8, 10, 12, 14, 16, 18. Now that's 18, but sulfur doesn't have 8 around it. Sulfur only has 6. So in order to change that, to give sulfur more than 6, make sure it has 8, we're going to put a double bond on oxygen. So now the first oxygen on the left has 8, sulfur has 8, and the oxygen on the right has 8. I can do this. I can add a double bond to only certain elements. And the elements are carbon, nitrogen, oxygen, phosphorus, and sulfur. We shorten it and call it CNOPS. If it is a carbon, nitrogen, oxygen, phosphorus, or sulfur, we can add a double bond to make sure that everybody has an octet and everyone is happy. So let's look at SO3, 2 minus, which is sulfate. Again, 6 plus 3 times 6, and now we've got to add 2 because it's a minus 2 charge. So we have 18 plus 2 is 20, so now we have 26 electrons, or 13 pair, that we have to deal with. Remember, the least electronegative element goes in the center. So now we have oxygens all around. So I have 26. I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26. Well, let's make sure. I don't think I did that right. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26. I did do it right. But 8 times 3 is 24. 8, 10, 12, 14, 16, 18, 20, 22, 20. That's 24. I can't count. That makes 26. Okay, so now everybody's good. I have 26 electrons. I put them all around, and everybody has 8 electrons around them, so they're good to go. Now let's look at SO4 2 minus. So now we have 6, and we have 4 times 6, and we also have a plus 2. So 4 times 6 is 24. Plus 6 is 30 30, so that's 32 electrons. Sulfur goes in the center. Now we have oxygens all around. Well, 8 times 4 gives me 32. So I can easily, everybody has 8. There's 32 electrons there. So consider the structures and which has the shortest SO bond. I'm hoping that you say SO2 because you see a double bond right here. Double bond. That means it has the shortest SO bond because all the other ones are single bonds or sigma bonds. Remember, you can only double bond things if it's a CNOx, which is carbon, nitrogen, oxygen, phosphorus, and sulfur.